You're here because you want to learn how the shunt clipper circuit works. So let me tell you what's here in this video for you. Here we are going to learn how all these types of shunt clipper circuit works with live multisim simulation. Most of the students feel more confident when they learn something through live simulations. And in this video, I'm going to explain all these things with live simulations. If you want to learn anything particular, then here is the timestamp for you. You can directly jump to that timestamp and learn particular thing you want to learn. So with all these things in mind, let's quickly jump to the video. So first of all, we'll start with shunt positive clipper. So let's have a circuit for that. The circuit is ready and let me explain few of the things. This is our supply voltage. Instead of 120 volt supply, we are going to use 5 volt 50 hertz supply. Because in my these two previous video, I have used the same settings where I am explaining trick to draw output waveform of series and shunt clipper circuit. And in another video, I am explaining all types of series clipper circuit using multisim simulation. So to keep similarity in between my all videos, I am going to use the same settings. And even that would be helpful for you all too, because if all the parameters are similar, it would be easier to compare these two waveforms of series clipper circuits and shunt clipper circuits. This is the oscilloscope using which we are going to observe the waveform. This is our load resistance. Together, these two is the clipper circuit and this one is the supply. Now we are going to run the circuit, but before that, we are going to change the color of output waveform. So we'll go to segment color, make it blue and okay. And now let's run the circuit. So this is the output. Stop it. We will reverse the background. If you want to learn how to use this oscilloscope in Multisim, then I have prepared a separate video for that, and this is really interesting things to learn. And now over here, let's understand how this things works, and to better understand, let's reduce the horizontal scale. This red one is the input and this blue one is the output. To understand the operation, we can divide this full operation into two halves, first half and second half. In first half, this diode will be in forward bias condition and in second half, it will be in reverse bias condition. How it is happening? Let's see. In this positive half, the supply voltage is like this. That means this terminal is positive as compared to this terminal. So this effect of plus will reflected over here and the effect of minus is reflected over here. And because of this polarity, this diode will be in forward biased condition. When this diode is in forward bias condition, current will start flowing in this path. And because of this, the voltage drop across these two terminals, which is equal to 0.7 volts, because it is silicon diode, right? So this voltage drop is 0.7 volts. And that is why we are getting this much of voltage over here. Almost 0.7 volts we are getting in positive half cycle. But when the negative half cycle starts, in that condition, this terminal will be plus and this terminal will be minus. So because of this, the polarity across the diode looks like this. So in this polarity, the diode will be in reverse bias condition. And when it is reverse bias condition, it behaves as open switch. When the switch is open, current will flow through this load resistance. And when the current flows through this load resistance, whatever the supply voltage we are having, all the supply voltage will be reflected towards the load resistance. And that is why we are getting this voltage in output. But you can see over here, there is the difference between the peak of supply voltage and the load voltage. Though the channel B and channel A having the same vertical scale. Now, what is the reason behind this? The reason is when there is a negative half cycle, there are two resistance in series. resistance number 1 and resistance number 2. So the supply voltage is divided across this resistance as well as this resistance, and that is why we are getting little less output voltage from the supply. So this is how the shunt positive clipper circuit works. Now it's time for shunt negative clipper. And to understand that thing, let's remove all these things. We'll prepare circuit for that. And now let's run, stop it, rearrange it, and you can see the waveform. Now let's understand how this functions. The same way as previous one, to understand this operation, we'll divide into two sections. In section number 1, the polarity of supply is like this. So the effect of this on diode is looks like this. And when this terminal is positive and this one is negative, the diode in reverse bias condition. When it is reverse bias condition, it behaves as open switch. And because of these things, current will flow through this resistance and we'll get whatever supply voltage we are having in our output. So that is why this full output voltage we are getting. Now if we talk about second half, then the polarity in second half, this one is plus and this one is minus. When it is the polarity, this is plus, this is minus, and this diode will be in forward biased condition. When the diode is in forward bias condition, current flows through the diode. Instead of flowing through this R2 resistance, current will flow through this diode D1. And when current flows through this diode D1, the voltage drop across these two terminals will be 0.7 volts. And that is why in output we are getting 0.7 volts constant. So this is how the shunt negative clipper circuit works. Now we are going to understand shunt positively biased clipper. There are two types of clipper: shunt positively biased positive clipper and shunt positively biased negative clipper. So first of all, we'll go for shunt positively biased positive clipper. So first, let's have circuit for that. So this is the circuit of shunt positively biased positive clipper. Now here we are going to change the voltage from 12 volt to 3 volts, because in our previous video we have used that thing, and instead of V2 we'll label it as VDC. So now let's run it, stop it, bring it to front, reverse it, bring it to front. This is the voltage of all the sources. The red one is AC source and the blue one is DC source, and this one is the output voltage. Now to understand the operation of shunt positively biased positive clipper, we can divide this full operation into three modes. Mode number 1, mode number 2, and mode number 3. So the first of all, let's discuss the mode number 1. In this mode, the supply voltage is less than the DC voltage. So we can write Vs is less than VDC. This is the mode number 1. When the supply voltage is less than VDC but the polarity is like this. So this one is the positive terminal and this one is the negative terminal. But this positive terminal, the magnitude of this positive terminal is less than this positive, because this terminal is at 3 volt and this terminal, let's say for example, it is at 0.5 volt. Though this supply voltage is in positive half cycle, but the effect on this diode D1 is like this. This terminal is at negative potential with respect to this terminal. Anode is at lesser potential than the cathode. And when this is the case, this diode will be in reverse bias condition. When the diode is in reverse bias condition, what will happen? Whatever supply voltage we are getting, that will be reflected in output. Why it is like this? Let me explain that thing. Let me remove this things. And now let's see. When this diode is open switch, this entire lag is disconnected from the circuit, and that is why all the supply voltage is directly reflected to output. And that is why you can see in mode number 1 the output is following this supply voltage waveform, right? Now let's discuss mode number 2. In mode number 2, the supply voltage is greater than VDC. And when that is the case, let's say this terminal is positive, this one is negative, and this terminal is at 4 volt, right? And this terminal, it is DC, so this is constant, it is at 3 volt. So in this case, anode is at 4 volt, cathode is at 3 volt. So this diode is in forward bias condition because anode is on higher potential than the cathode, and that is why the current will flow and diode will behave as closed switch. And when this diode behaves as closed switch, let me remove all these things and explain that thing. The circuit looks like this. So the voltage drop across these two terminals is 0.7 volts and we are having 3 volts. So total voltage we are getting across these two terminals is around 3.7 volts. And that is why if you measure voltage at this point, let me show that voltage to you. Bring this line and see, at that point you are having 3.586 volts. So it's almost 3.6 volts, right? And I have told you it is 3.7 volts. So during entire mode number 2, the output voltage will be clipped at 3.7 volts, practically 3.6 volts. Now let's discuss mode number 3. Mode number 3, again supply voltage is less than the DC voltage. This mode number 3 is similar to mode number 1. Practically there are only two modes where supply voltage is less than DC volt and when the supply voltage is greater than DC volt. But I have taken this mode number 3 because if we consider this mode number 3, the entire first cycle will be covered. So if we discuss about mode number 3, it behaves as same as mode number 1. And that is why we are getting full cycle of mode number 3, full cycle of supply in output in mode number 3. So this is how this shunt positively biased positive clipper works. If you have any doubt in this, you can directly ask me in comment section below. Or else, you know what? To make this type of video, it requires lot of hard work. And to support my hard work, you can at least give me a like. And if you want to learn similar things, then you can subscribe to this channel. Because your one likes motivates me a lot. Now again, get back to the topic. And now we are going to discuss shunt positively biased negative clipper. So we will remove all these things and let's prepare the circuit. The circuit is ready and now we are going to run the circuit. First of all, we'll open both the oscilloscopes and now let's run. Stop it. So this is the output of shunt positively biased negative clipper. So to understand the operation, again we'll do the same thing. We'll divide entire operation into three modes: mode number 1, mode number 2 and mode number 3. So let's discuss mode number 1 over here. When the supply voltage is less than the DC voltage, and when this is the case, let's understand this thing in the circuit. This terminal will be positive and this will be negative. The anode of this diode will be continuously connected to 3 volt because we are having supply voltage, DC supply voltage of 3 volts. Now on the anode side, let's say we are having 0.5 volts. So this terminal is at 0.5 volts and this terminal is at 3 volts. So what do you think? Tell me your opinion. that whether this diode will be in forward bias condition or in reverse bias condition. You have only two options. Choose wisely and write the answer in comment section below. So now let me tell you that this diode will be in forward bias condition. And when this diode is in forward bias condition, what will be the condition? This diode behave as a closed switch. So the simplified circuit of this entire lag looks like this. The voltage drop across this diode will be 0.7 volts, and over here we are providing 3 volts. So the total voltage we are going to get over here, that is not 3.7 volt. In our previous case we have seen that we will get 3.7 volt, but not in this case. Why we are not getting 3.7 volt in this case? Let me explain that thing. Because in this case whatever supply voltage we are having at these two terminals, that will be provided by this DC source, and when this DC source is providing that voltage, current will flow in this cycle. And when the current flows in this manner, if we apply KVL, then according to that KVL we should subtract this 0.7 volt from this 3 volt, and if we subtract that thing, then we'll get almost 2.3 volts across these two terminals. So now let's verify that we are getting 2.3 volts or not. Let's bring this over here, and you can see it's 2.494 volts. So it's almost we can call it as 2.5 volts. So instead of 2.3 we are getting, practically we are getting 2.5 volts, and theoretically we are getting 2.3 volts. So this is how this circuit functions in mode number 1. Now let's understand mode number 2, and for that let's remove all these things. So in mode number 2, the supply voltage is greater than DC voltage, and when this is the case, this terminal is plus, this terminal is minus. Over here we are having let's say 5 volts, and over here we are having 3 volts. So what do you think? This diode will be in forward bias condition or in reverse bias condition? When anode is at 3 volt and cathode is at 5 volt, this diode will be in which condition? Write the answer in comment section below. So the diode will be in reverse bias condition, and when it is in reverse bias condition it behaves as open switch. So this is how this entire lags look like. So this DC source will be disconnected from the circuit, and whatever supply voltage we are having will get it in output, and that is why in entire mode number 2 will have output voltage the same as supply voltage. The waveform will follow the same pattern, but the magnitude will be little less than the supply voltage, because this R1 resistance is also connected in series with the R2. So some of the voltage will be dropped across this R1 resistance. Let me show you what is the difference in the output voltage. At this peak, the supply voltage is 7 volts, and at this peak the output voltage is 5.8 volt. So almost a difference of 1 or 1.2 volt we can see in output. So this is how shunt positively biased negative clipper works. Now it's time for shunt negatively biased clipper. So for that, let's quickly prepare the circuit. So the circuit of shunt negatively biased positive clipper is ready. Now we'll open both the oscilloscope and run the circuit. Stop it. Bring this thing to forward and bring this thing to forward too. So from these waveforms you can see that this DC supply is negative now. So this is shunt negatively biased positive clipper. To understand the operation, we can divide this entire operation into two halves or into three halves. right? Mode number 1, mode number 2, and mode number 3. Mode number 1 and mode number 3 will be similar, and in that case Vs supply voltage is greater than DC voltage. So we'll be understanding mode number 1 and 3 together. And for that, let's come to this point. This terminal is positive and this terminal is negative. When this is the case, this one is positive and this one is negative. Now, let's suppose this point is having 3 volts. So when this is the 3 volt, anode is at 3 volts and cathode is at 0 volt, the diode will be in forward bias condition and it will behave as a closed switch. When it is a closed switch, the circuit looks like this. When this is the case, then current flowing through the source will flow in this loop and current flowing through this DC source will flow in this loop. So if we apply KVL over here, we'll get the output voltage, this 3 volts minus this 0.7 volts drop across this D1 diode. So that will be almost equal to 2.3 volts, but that will be minus 2.3 volts. So let's verify it through the simulation. And over here you can see that we are having minus 2.346 volt in output. So it is almost 2.4 volts. So when this is the case, when mode number 1 and mode number 3 is there, we'll be having constant DC voltage in output. Now we'll discuss about mode number 2. When this is the case, supply voltage is less than DC voltage. So to understand that thing, we'll remove all these things and we'll see the supply voltage terminal. This will be plus and this will be minus. And let's suppose this terminal is at 5 volt and this terminal is at 0 volt. Now this mode number 2 is very tricky. So provide your 100% focus in this video. Otherwise it will be a little bit difficult for you to understand the operation of this mode. For example, the supply voltage is 5 volt. That means this terminal is at 5 volts, right? Or we can call it as negative 5 volt. But instead of speaking negative 5 volt, we'll speak it as 5 volt. So when this is at 5 volt, this terminal 2 is at 5 volt. When the positive terminal of the battery at 5 volt and the battery voltage is 3 volt, this means the negative terminal of the battery is 3 volt less than this voltage. So in this condition, this terminal will be at 3 volt less than this 5 volt. That means this terminal will be at 2 volts. Now this terminal is at 0 volt, this terminal is at 2 volt. What does it mean? Anode is at 0 volts and cathode is at 2 volts. That means cathode is at higher voltage and anode is at lower voltage, and that clearly shows that the diode will be in reverse bias condition. When the diode is in reverse bias condition, it will behave as open circuit, and when it is open circuit, this battery will be removed from the circuit. The circuit will looks like this. So the battery is removed from the circuit, and that is why whatever supply voltage we are having will get that voltage in output. And that is why in entire mode number 2, whatever supply voltage waveform, the output voltage will follow the same. And in mode number 3, the operation is same as mode number 1. So this is how shunt negatively biased positive clipper works. Now it's time for the next clipper, and to understand that thing, let's remove all these things. The next clipper is shunt negatively biased negative clipper. So let's prepare a circuit for that. The circuit is ready. We are going to run, stop it, bring it forward 2, and now let's understand the operation. And for that, the same way we will divide this operation into 3 modes. Mode number 1, 2, and mode number 3. This mode number 3 is basically lasted up to this point, and it is basically the same as mode number 1, right? So practically if we observe, then we have only two modes. In mode number 1, the supply voltage is greater than VDC, and when this is the case, let's understand what happens. This terminal is positive and this one is negative. Let's say this terminal is at 4 volts, this will be at 0 volts. So if we consider this as our reference point, this is at 0 volt, that means the positive terminal of the battery is at 0 volt, so the negative will be at minus 3 volts. So the anode will be at minus 3 volts and cathode is at 4 volts. So looking at this condition, it is very clear that this diode is in reverse bias condition, and when this is the case, the circuit of this lag looks like this. And when this is the case, whatever voltage we are getting in supply, all the voltage will be reflected in output. So up to here, for entire mode number 1, the output voltage will follow the waveform of supply voltage. Now if we talk about mode number 2, over here the supply voltage is less than VDC voltage. Now let's remove all these things. Right now this terminal is positive and this will be negative. For example, we are having 5 volts. So we are having 5 volts at this point. When this is the 5 volt, and here we have 0 volt. So this terminal is at 5 volt. That means the positive terminal of the battery is at 5 volts. That means the negative terminal of this battery will be at 2 volts, because the battery is having 3 volts of potential difference between positive and negative terminal. So this terminal is at 2 volts. That means anode is at 2 volts and cathode is at 0 volt. This clearly shows that this diode will be in forward bias condition, and when this is the case, the circuit looks like this. And whatever voltage, whatever DC voltage we are having, that DC, that constant voltage will be getting in output. So let me tell you what will be the output voltage. So in output condition, we are having this 3 volt of DC supply. To understand this thing, let me remove all these things. The battery is of 3 volts, right? So if we apply KVL over here, the battery is of 3 volts and this diode is having 0.7 volts. Now in this case, we are not going to subtract this 0.7 volts from this 3 volt battery, because the current flowing through this diode, that is because of this supply voltage, right? So the entire voltage we are getting across these two terminals will be because of this supply voltage. So this 3 volt plus this 0.7 volts, so we are going to get 3.7 volts in output. And let's verify that what we are getting in at output. Let's bring these points to here and observe that we are getting 3.580. So it is almost 3.6 volts we are getting in output, right? Almost 3.6 volts we are getting in output. Now here there is one key thing to understand. When we are subtracting this 0.7 volts from this DC voltage, and when we are adding this 0.7 volts to this DC voltage to get exact output voltage. So here is the trick. So when current flowing through the diode is because of this battery, you need to subtract the 0.7 volt from this battery voltage. But when the current flowing through this diode is because of this supply voltage, at that time you need to add this 0.7 volt into the battery voltage to get the output voltage. And this is the simplest trick. So this is how shunt negatively biased negative clipper works. So this is how shunt negatively biased negative clipper works. If you want to learn how the series clipper circuit works, then you can check out my this video. If you want to learn the trick to draw output waveform of series and shunt clipper circuit, then you can visit the playlist Multisim tutorial on my channel's page. There you will find many useful videos for you. So until we meet again in our next video, till the time, bye bye.